Thank you. It's a great pleasure to be here. Thanks for having me. It's wonderful to be among developers to talk about stuff that we all like to talk about and think about. So I want to talk about code quality. Code quality is something near and dear to me. I care a lot about writing code that's actually maintainable. Well, oftentimes what we find ourselves doing is we optimize for our ability to write code. And in the process, we tend to forget that what's really important is reading code and maintaining code. We write once, but we rewrite several times. We read code several times. I'm also a why kind of a guy. I always want to ask the question, why do I want to really improve the quality of code? Because if we don't know why we are doing it, there's not enough motivation to do it. So I'm going to say, well, most organizations today are agile. It's hard to come by an organization which says, we're not agile. Everybody wants to be agile. But it turns out that if we don't have a poor quality code, it becomes really hard. We cannot be agile if our code sucks. That's one of the biggest challenges. You're sitting in a meeting, they're suggesting to you that we should really improve, enhance, add a feature to the application. And you realize to do this, you have to make change to that XYZ module. And you realize the last time you touched the XYZ module, you couldn't go home for the weekend. You're going to convince them, no, we don't want to really implement this feature. So it's really hard to effect change in software when the quality of code is really poor. But there's another reason why we really want to have good quality code. The quality of code reflects a lot about what we think and how we work. And it turns out code is how we tell our colleagues how we feel about them. Do we really love our colleagues? Do we hate them? So that makes a big difference in how we write the code, because when we sit down, when people sit down to make the change to the code we have written, they're going to sit there and stare at it, try to understand. And how many times do you hear people cursing when they are reading code? That happens a lot because it becomes very frustrating over time. So it turns out that the first law of programming says lowering quality of code lengthens the development time. So if you really want to go slow, create poor quality code, and it naturally slows you down. And that becomes really hard to maintain the software over time, and the speed comes down quite a bit. So if you really want speed in developing software, we should really maintain that particular thing in the systems to say, we want the sustainable speed, so we want quality to support it. That becomes extremely important. But we can talk about quality, but quality is very qualitative. How do we know if a piece of code is of good quality or not? How do we say that? So I'm going to say the way I would like to measure the quality of code is this. The quality of code is inversely proportional to the effort it takes to understand it. If a particular piece of code takes a lot more effort to understand, it usually is a poor quality. And I do a lot of code reviews, and I often tell people, if I spend more time on your code, that's a reflection of poor quality. If I come in, I understand what the code is doing, and I walk away from it, that's a good thing. So you want the code to be really expressive, intuitive, and not have surprises in it. That becomes very important. So the quality of code is something we could say is inversely proportional to the amount of time and effort it takes to really understand that code. So I want to talk about 12 ways in which we can improve the quality of code. And I'm going to count down here. So the first of the 12 I want to talk about is to schedule time to lower technical debt. Now, technical debt is a term that was coined by Ward Cunningham. And when he worked on projects that involved the financial industry, he realized there's a similarity here between what we talk about as the debt in the financial world to the debt we come across in the programming world. And so he coined the term technical debt. Now, if you're talking to a friend or a family member who has a financial debt, what do you normally do? The first question you ask them is, how much debt do you have? And if they say, I don't even know how much debt I have, that means real trouble, isn't it? So you're going to ask them, what are your debts? And then once you find out what their debts are, what's the next thing you do? You first tear up their credit cards. And the second thing you do after that is you start listing all the debts from the most interest paying to the least interest paying, and then you put them on a budget and a regimen to start paying those debt. That's exactly with technical decisions as well. When you're dealing with technical debt, well, the first question to ask is, what are your technical debt? Well, it turns out a lot of companies, I work with a lot of companies, I go in and work as a consultant, and I would ask them, what are your technical debt? And shockingly, many different teams don't have a clue what their technical debt is. Sometimes it's easy not to know those things, right? Because it's scary. If you put it down, it's going to be really scary. Well, what happens when the technical debt becomes enormous? Well, exactly what happens when the financial debt becomes enormous. When financial debt becomes enormous, it leads to financial bankruptcy. So let's say I go get a credit card, I charge a credit card. At the end of the month, I realize I don't have to pay the amount. All I have to do is pay only a small amount of the money from the credit card. So this becomes really, awesome, right? I don't have to pay everything I charge for. Well, if I continue with this, in a few months, I realize that I've exceeded my credit limit. So what happens when I exceed my credit limit? The bank immediately sends me a mail, right, and says, "Dear Venkat, you have exceeded your credit limit." But you see, the bank cares about me, right? So they extend my credit limit, they increase my credit limit. Because the bank does not want me to get into trouble. They want me to get into real trouble. So now after about a year or so, I keep charging, and at some point, the amount I owe on this credit card is more than my yearly income. And now what do I do when the amount I owe is more than my yearly income? Well, there are only a few options. One thing I can think of is to change my name, grow a beard, and move to another state. Just for the sake of records, that's not the reason I left Texas. So the point really is, we can't really cope up with this kind of debt when this happens. Well, this is exactly happens to projects as well, when there is a huge amount of technical debt on projects. I'm sure you worked on projects like this, right? Everybody is leaving. Nobody wants to work on the project. And the people who get hired on the project, they're called victims, right? And nobody wants to work on such projects because it's unbearable to work on these projects. So we want to really take the time to pay these technical debt. That's extremely important. So, but what is a technical debt? Technical debt is really not poor, low quality code. Creating low quality code is a sabotage. But technical debts are things that incur over time. Oh, that schema has evolved over time. It quite doesn't meet our current expectations. We got to refactor the schema, but we haven't had time to do it. Oh, that other XML processor we've been using, that's gone out of date and stale. We haven't had time to upgrade it. Oh, look at our warnings from our library. There are so many deprecated methods we are calling. We just haven't had time to go fix it. All of these become technical debt over time, and we got to take the time to fix them. But if we never take the time to fix them, it only becomes unbearable over time, and that becomes very expensive to maintain the code. So what can we do about this? It's not an all or nothing proposition. The first thing I would say is list down your technical debt. The second is schedule time to pay the technical debt. When you're going through sprints, when you're going through iterative development, in your sprint cycle, you want to dedicate some time for paying these technical debt. So in other words, don't take all your time on your sprint and schedule it for development work. You are going to schedule significant time on development, but you also are going to have some time that you're going to dedicate for example, planning. But you also have to spend some time to pay your technical debt as well. Whatever the time is, 10%, 15% of your schedule, you want to devote towards paying technical debt. If teams do not actively schedule time to pay technical debt, then that goes kind of unnoticed over time. We keep complaining about it as time goes on, but we never actually take the time to really proactively address it. That becomes a problem. But in addition to paying technical debt, there's something else we have to think of also. And I listened to this from this lady here, somebody whom I really admire a lot, Linda Rising. And she's written some really interesting books, but one thing she said really stuck to me. She said that not only do we have to worry about all the schedule we do, she said that a freeway which is packed with cars becomes a parking lot. That is so true, though, if you really think about it. If every lane on a freeway has cars going, how does it end up? If very quickly we get into a traffic gridlock and we cannot really move and it becomes a parking lot. Everything goes very slowly. It's the same thing with our schedule. If you fill up 100% of your schedule to do work, then you will never be, as an individual, and as an organization, you will never be able to innovate. This is something I'm taking to heart myself, and I'm learning from this, and I'm trying to reduce what I schedule in my calendar, because if I schedule every single day with work-related stuff, then there is no time for me to innovate and think about and how to improve things. That becomes really, really hard. A book that I really liked a lot reading was this book called Guns, Germs, and Steel. And in this book, he talks about something really wonderful to think about. He talks about, world and how people were. And there was a time when humans were savages. Today, there are a few people who are like that, but most of us are civilized. And there was a time when humans were savages. And they had to get up in the morning, and they had to go to hunting if they wanted food. And if they don't go hunting, they're going to starve that day. Well, if you don't have food, and if you have to go hunting to get food, what is going to be your priority the minute you wake up in the morning to go hunting? Well, there was no time at all to do anything else because hunting took so much time and effort. Well, eventually humans figured out two things. A, that they could do agriculture. They could grow things, and you could then save them away, and then you could eat them. And also they figured out you could actually domesticate animals. What a novel idea. You could bring a goat, keep it with you, and when you're hungry, you could kill it and eat it. This is awesome, isn't it? So this gave an opportunity for them to say, hey, what are you doing today? Well, I don't have to go to work today because there is enough food. Look at all these sheep we have around us and the grains we have. We could cook something and eat. Well, what do you do if you don't have to go to work? Well, you create art, you create music, you create civilization. So his argument is civilization really started when humans figured out agriculture. This is so true for what we do if you really think about it. If as a project manager, if I put you to death by work, you have no time at all to do anything else other than just doing the work. You don't have time to improve what you do because you're so busy doing what you have to do. So as an individual and organization, we really have to take the time not only to schedule time for technical debt, but also to have a slack time when we don't have to go do the work, but we have the ability to think back and say, how can we improve on what we do? That becomes extremely important. Well, the next thing I want to talk about here is to favor high cohesion. So what is cohesion? Cohesion is where like things are together and unlike things or dislike things are apart. So you want to make things very cohesive. So what does cohesion mean in our world? Well, I'll give you an example of this. When I was a kid, my parents really tried hard to teach me cohesion. They told me, Venkat, you got to put your clothes where the clothes belong, books where the books belong, and so on. I never listened to them. I would come home from school, open a drawer, throw things in it, and it was optimized for throwing things in. Because when you come back from school, you can open the drawer, throw everything in there, your clothes are in there, your books are in there, your toys are in there, you don't know what else is in there. Well, but when you want to take things out, it took a very long time. You found a blue sock, the next sock you find will not be blue in color. You got to search for where you're looking for. That didn't work very well. It was a pile of mess. I know what you're thinking. You're thinking, boy, you were a terrible child. How did you turn up to be the way you are? I got married. That fixed a lot of things for me. So the point really is that now, of course, this wonderful concept, my bookshelf has books in it, not a fork, not a knife, but just books. My kitchen has utensils, not books and clothes. And my clothes are in where they're supposed to be. And there's harmony in life. This is cohesion. Same thing with code. I'm going to ask you the question, raise your hand, if you think putting business logic in the GUI is a good idea. Well, not a single person raised the hand. Let me ask you a different question. Raise your hand if you have seen business logic in the UI. Yeah, the hands go up, right? So that is example. I know you all didn't do this. Somebody else is doing this at work. But the point really is that is a lack of cohesion. So cohesion is where like things are together and unlike things are apart. And so the code has to be narrow, focused, and do one thing and one thing really well. That is cohesive code. But the question is, why? Why should I make the code cohesive? And the answer is, it really comes down to the economics of software development. You want to reduce the frequency of change to code. Well, software is going to change. If somebody comes to you and says, they wrote a software, but they never had to change it. What they're telling you is their project got canceled because any project that's relevant has to change. But the key is you don't want to change a software by changing a lot of things in it. You want to be able to change the software by making minimum set of changes to it, and that's where it becomes really economically viable. So you want to reduce the frequency of change to the software. That becomes extremely important. So high cohesion usually leads to low complexity in code, and so we want to really make the code high in cohesion. But the next thing to think about is to lower coupling as well. So what is coupling? Coupling is dependency. And the more the dependency is, the harder it is to extend the software. It becomes really hard to test the software as well. So you want to reduce coupling as much as you can. But even more than reducing coupling, I would encourage you to eliminate coupling wherever that's possible. Why should we eliminate coupling? If we eliminate coupling, it actually becomes even more easier to maintain software. Now, eliminating coupling may not be an option a lot of times, but what I mean by that is to move the coupling from one place to another. Let's look at an example. So here is an example of a code that's in the middle that I want to really test. But the code in the middle is actually talking to the code on the right side. Well, that dependent object, the one on the right side, red in color, is actually pretty non-deterministic. It could be giving you the current weather, for example, or it could be giving you a stock data, something very unpredictable, or it's going to tell you who is going to win the election, for example. So a lot of these things are pretty unpredictable, as you know. Well, but if my code is depending on that particular piece of code, how do I really test it? Well, one way to test that code is to start creating mock objects. Well, those of us who have created mock objects know where this quickly goes into. It goes into this beautiful world I like to call as mocking hell. Because the mocking hell is not a very pleasant place to be. They torture you once you get there, right? And mocking hell becomes really hard to maintain code. So how do you avoid it? Well, what we could do in this case is to move the dependency. So we could take the dependency on the right side and move it to the one to the left of this particular code. Well, the beauty of this approach is the code on the left now gets the data and passes to the code that we are testing. Well, it so happens now that the code in the middle becomes, one which was in the middle, now becomes very easy to test compared to previously. We don't need any mocks on this code for testing purposes. But of course, we need some mocks on the code on the leftmost part right now, but we need to only create a fewer number of mocks now than before, and as a result, the testing becomes a lot easier to work with. So that is something for us to think about. So I talked about paying technical debt. I talked about keeping the code very highly cohesive, to lower coupling or reduce coupling. But one other thing to think about is to program with intention. Well, sometimes we program accidentally. How many times have you seen people write some code and you ask them, why did you write this? And they're like, I don't know. I was just writing this code. I thought I had to handle all these conditions, and we accidentally end up writing this code. But we want to really program with intention. Well, I came across this on Stack Overflow, which really represents our feelings. It says that when I wrote this code, only God and I understood what I was doing. Now God only knows. So we see this a lot of times, isn't it? So this becomes really hard for us to maintain code because we don't understand what the code is doing. It's extremely hard to understand. The code becomes very opaque, and the cost of maintaining this code really goes up. And so we have to really take the time to lower these and make the code very clear, the intention to be really very clear also. That becomes extremely important. So how do we go about writing code? Well, one of the things that I really like about is the so-called rules of simple design by Kent Beck. And he talks about 4 different rules. He says the first thing is passes all the test. There's an implicit assumption there, as you can see, that we actually have tests. But it passes all the tests. The second thing he talks about is reveals intention. And then there are no duplications in code. And then finally, fewer elements. The last one actually is one of my favorites. Having minimum number of elements, minimalism is something I care a lot about. Maybe I go to a little bit more extreme than I should, but I try to keep things extremely minimal when I write code. But the second point here is that code reveals intention. We want to really make it very highly expressive. That is very, very important. So we want to program very deliberately. One way to program very deliberately is to write test before writing code. This is one of the reasons I really like test-first development. So one of my mantras is write test and then write minimally code to make the test to pass, and that can help us to really drive towards a minimalistic code, but also to program very intentionally. Because your test is specifying the intention and forcing the code to only serve that intention, so we can be very deliberate in our programming effort by writing these test cases. Well, we want to program deliberately, but we also want to program fluently as well. And this is a problem that plagues a lot of developers. And that is, we want to avoid primitive obsession. What is primitive obsession? Primitive obsession is where we take upon ourselves that we have to write every single piece of code. And sometimes this happens. The other day I was looking at a piece of code, and there was a good 10 to 15 lines of code, I'm not kidding, and I'm reading this code back and forth trying to understand what the code is doing, and then I realized, oh my gosh, this developer took 15 lines of code to do what is already available in the JDK, and you can do that with a single line of code. All I did was I commented out that 15 lines of code, made one call to the JDK, saved the file, all the tests passed. I quietly checked in the code for the developer to discover this. And sometimes we see people do this. They write way too much code than really needed when that code already is there in another library we could readily use. Let's look at an example of this. I'm going to say imperative code is packed with accidental complexity. We have been programming in imperative style for a good 20 plus years, which means we've been programming with more complexity naturally in what we've been doing for all these years. Let's look at an example to see how this actually works. So here is an example. Is prime is a function that tells you whether a given number is prime or not. Don't worry about its implementation right now. Then I have an n and a k, and I want to call the compute function. And what does that function do? Find the total of the square root of the first k prime numbers starting with n. So let's do this. So I'm going to say int index equal to n, and then I'm going to say int count is equal to 0, and then double total equal to 0. Well, what did I do so far? Did absolutely nothing useful. All I did was I initialized a few variables. How do you feel when you have to keep initializing variables without having to really get to the real work? You feel like it was a very tiring, hard day at work, right? You go home and say, it was a wonderful day, I did a lot of work. For what? Not a whole lot of result though, right? That becomes really frustrating. Well, then I'm going to say, while count is less than k. Stop, you have to ask the question, is it less than or equal to? Do you ever ask this question? Every single day. And the day you forget to ask the question is called the National Off by One Error Day, right? How do you feel when you have to stop and ask that question every single day? You feel stupid, don't you? Because you look at the code and you look away and you look at it again, it's like, did I do this right? Is it less than or equal to? And you always carry this fear. Did I do it wrong? And then what do you do after this? Then you say if is prime of index. Well, if it's a prime number, what do I want to do then? Well, I'm going to say total plus equal to math dot square root of index. And then when I'm done with it, I'm going to return the total. Is this code correct? No, I hear no. What's wrong with this? I have to increment the count, he says. So let's increment the count plus plus. Is it done now? What is wrong? He says I have to move it outside over here. Is this correct? Yep. He says yep with confidence. Okay, are we done now? I have to increment the index. Okay, index plus plus. Is it good now? Is it good? He says move it up. What's wrong with you? He keeps me to move up and down, right? Just kidding. But, oh, you know, he wants to reverse it. He says put this inside and put this outside. Isn't that a beautiful game we play? Now, is it correct now? Oh, see that? You heard this answer, right? He says, it looks good. Programmers are really smart. They never say it is correct. It looks good. Because tomorrow when you find it's wrong, you say, it only looked good. I didn't say it was right. So it looks good, right? Well, maybe it looks good. Let's run it and see what it does. Well, it gave a result, but look at the code. You look at this code and you're not sure if it is correct. If you show this to somebody and say, what does this code do? And they are like looking at it, they look away, they look at it, and they say, let me think again, right? So I have an answer for you. It is code like this that prematurely turns programmers into managers, right? Because they look at this and say, I'm done. I'm not going to do this. I'll let you clowns deal with this. I'm going to sit and watch. I'm going to manage you guys do this, right? So people don't stay in programming for too long when they have to deal with this. This is why people come into programming and they're like, where's the exit? I want to be a manager now, right? And this is really sad because we need qualified technical people, but they're like, no, I've got children at home I've got to go feed. I don't have time to put up with this nonsense code, whether it works or not, moving this up and down, not enough time in a day. Let's try this one more time. What I want to do, though, is rather than mess with that piece of code, which is a lot of effort, what do I want to do? I want to change that really to return stream.iterate. So stream.iterate, well, where do I start? N, and given an element plus 1. You say, wait a minute, what in the world is that? That's an infinite stream. Well, wait a minute, if it's an infinite stream, how long is it? Duh, it's infinite, it's long, that long. Well, if it's infinite, where do you store it? On the cloud, of course. So this is an infinite stream, right? But the beauty of the infinite stream is you can say filter, and then you can say sample is prime. Well, give me all the prime numbers now. Then I want to map math square root. Give me only the square roots, but limit it to k values. Is it less than k? Is it less than or equal to k? It's k, damn it, keep moving. There's not a whole lot of time to spend on it. And then I say sum this and return the sum. So you can see in this case, we can write the same code, but with a lot less effort. It's a single pass through the code rather than having to go back and forth. There's no moving increment up, moving increment down. There's no garbage variables. The code becomes highly expressive. Of course, we call this the functional style code. So this code becomes a lot easier to understand, easier to maintain, easier to work with, and that becomes a lot better in the long run. So what are we dealing with in this case? Well, a good code should be like a story, not like a puzzle. You don't look at the code and you're like, let me try to figure this out, right? It should be very obvious when you look at the code what the intention is. You don't want to be sitting there and staring at this code to figure out what it's really doing. It should be easy to grasp. So that becomes the quality of code. So on the left, you see the imperative style code. Imperative style code is where you say what you're doing, but you also have to say how to do it. On the right side is functional code, but every piece of functional code is also declarative in nature. So as a result, the code you see is declarative. You tell what to do, but not how to do it. It turns out functional code is declarative and also uses higher order function. So the real power of functional code in terms of expressiveness comes from declarative programming, not as much from functional programming in that aspect. So the next thing I want to talk about here is, yeah, you want to program with intention. You want to avoid primitive obsession, but you also want to avoid clever code. Now, why do we write clever code? We write clever code because it feels good. When you write clever code, you feel like you have done something useful, isn't it? In fact, when you write clever code, what happens? That proverbial hand comes out of your pocket and pats you on the back and says, you are awesome, isn't it? So it feels good to write clever code. But clever code eventually comes to really hurt us. I'll share with you an experience I had. I was working on a project when I got an email from a client saying something has to be fixed. And I looked at the solution, and honestly, I could have written the solution in 10 minutes. But why would you solve a problem in 10 minutes? I don't want to solve the problem. I want to solve the mother of all problems. And I said, I'm going to go meta. And I took an hour to solve this problem. And when I solved the problem after an hour, I felt so good because I didn't solve that problem. I solved a class of problems. And literally I had an out-of-body experience. I could feel Venkat get up, walk around me and hug me and say, "You're awesome, Venkat." This felt really good, right? Because I'm that awesome. I wrote this wonderful code. It felt that way. Well, about a couple of weeks went by, I got an email from the client. And the client said, something terribly has gone wrong in production and somebody needs to look at it. I looked at it and immediately replied to the client saying, "Hey, I got an idea what to do about this. I'm going to fix it. Don't worry about it." They replied back saying, "Oh, we know you're going to fix it because you are that good." I said, No. I can fix it not because I'm good. I can fix it because I'm the one who caused it. And it was that clever solution I wrote that completely backfired in production. So what did I do? I rolled back all my changes that I did, put back that little solution that only took 10 minutes and checked in the code. It's been 7 years, absolutely no problem. So these days I've learned my lesson. When I'm coding, I look at the code and my little brain says, "That's a clever code," I immediately delete it and I start over. I don't want clever code, I want clear code. That becomes extremely important. So one of the codes I really like a lot is this code. Programmers may written for people to read and only incidentally for machines to execute. That is something we have to be really careful about. Readability of code is extremely important for us to carry through. Well, I'm going to say 10% of the time we write ugly code for performance reason. The other 90% of the time, we write ugly code to just be consistent with that other 10% of the time. And we do this all the time. We are just focused on really creating that code, a very clever code to really write. So we have to be very careful in how we write the code. And those who sacrifice quality to get better performance may actually end up getting neither one of them. So we have to really work on creating a maintainable code that becomes extremely important. Well, Tony Hoare has this wonderful quote. He says, there are two ways of constructing a software design. One way is to make it so simple that there are obviously no deficiencies. And the other way is to make it so complicated that there are no obvious deficiencies. So the code is so complex, you don't even know what's wrong with this code, and that becomes very frustrating oftentimes. Well, the next thing I want to talk about here is something that's drawn my attention, which is so-called Zinsser's principle on writing. This is a source from which I got inspiration, which is very away from programming. There's a very old book, it's about 30-year-old book by William Zinsser on writing well. He talks about how to write good English, how to write nonfiction. As I was reading this book, I was so inspired about not only using these to write better English, but to actually use this to write better code, because things he talks about writing good English applies equally to writing better code as well. He gives you 4 principles, very, very nice principles. The first is simplicity. He says you have to keep things simple. Well, sure, he talks about writing English, but writing code, where does that matter? Well, think about simplicity for a minute. A code that has a lot of moving parts is not simple. A code that has very many mutability is not simple. A code that is not cohesive is not simple. A code that over-engineers solution is not simple. A simple code should fail more gracefully and fail less as well. So we care about simplicity when it comes to writing code quite often. He talks about clarity. He says what you write should be very clear. Same thing with code. What makes code really unclear? When the code is very long and non-cohesive, it's not clear. Or somebody writing code does something here, suddenly does something else here, and then suddenly changes another variable here. You're not able to keep the flow of the code in your mind. It becomes very confusing and it's not very clear. He talks about brevity. Keep things very short. And same thing in coding. You want smaller classes, smaller functions, as much as possible, smaller components. And we do this also. And the last thing he talks about is humanity. And this is the one I had most difficulty with, because I can understand humanity in other contexts, but we program a lifeless machine. Why would humanity matter to us? And I realized that when I go to developers and ask them how they would design some code, They tell all kinds of nonsense. But when I ask them, how would you really do this if you are doing this, a more lively design comes out. So we should really care about humanity. But not only do we have to care about humanity when it comes to writing code, remember, other programmers read our code. So we have to have empathy when we are writing code about other people who are going to read our code. That becomes extremely important. I know this is really hard, right? Because the other day I was with my optometrist, and she was looking into my eyes, and then she asked me, what do you do for a living? I said, I'm a programmer. She asked a few other questions, and then she came back and asked again, what do you do for a living? I said, I'm sorry, but I told you that I'm a programmer. And she said, yes, I know you told me that you're a programmer, but I had to ask you again because you look normal. And that is kind of the, people think, right, that if we are programmers, we should kind of look different, and we don't, socially interact. But the point really is that we should really consider humanity. That is very, very important for us to consider as well. Well, this one is very near and dear to me. I really, really hate comments. I want to comment why, not comment what. How many times you see comments that are absolutely useless when it comes to comments you see? The other day I saw a comment which was something like this. The comment said, very nicely, I++, semicolon, increment. And this was like very helpful, thank you. I was not sure. As I'm getting older, I'm no longer, sure. I just stare at it, it's like, oh yeah, it is an increment, thank you. Or even better, I'm sure you have seen your code like this. And then there is this code, and then there's a very helpful shift. They're like, thank you. I know you are shifting, but why the heck are you shifting? That's what I don't know, right? These are not comments. These are insult the programmer's intelligence, right? That's what we do with these kinds of comments. So we want to really comment, but only the why and not the what. I'm going to say most of the comments are written to cover up bad code. If a code is not understandable, I don't want to comment the code. I want to refactor the code. That is very important. Well, you want the code to be self-documenting and expressive. I'm going to say a good code is like a good joke. When was the last time you said a joke and everybody around you stares at you and one person says, so what's funny about this joke? The worst thing you can do when your joke falls flat is start explaining it. People don't hang out with people who explain jokes, right? This becomes very, very, very tiring. So what is the right thing to do? When you say a joke and nobody gets it, the only right response is, never mind. Forget it. Just pretend like I never said the joke. And then you go home, sit alone, and you think about this, and you refactor your joke. And the next day, you try the joke with a different group of people and see how it goes. And that's the whole point about jokes. You don't explain jokes, you just rework the joke. Same thing with code. A good code is like a joke, and you, by writing comments, is like explaining a joke. You just rework it, refactor the code, don't try to explain what the code is doing. Well, I want to emphasize this because we live in a world which has gone crazy. I was in Washington, D.C., and I wanted to take a shower. So this was my first day at that hotel. So I get into the shower. I should be showering. Immediately, I had to jump out of the shower, take a photo, and tweet it. I mean, we live in this world where you have to tweet immediately what you see. So forget showering. I got tweeting to do. So I tweeted immediately. I posted this picture. I was so angry because the shower said, pull to turn on. And I'm like, why can't you make it easy for me to use the damn shower, but you have to document it? So my claim is, those who cannot design are condemned to document. And this is what we see in every single API that we see. Everywhere you turn, there's a documentation. Int P1, int P2, int P3 parameters. What does that mean? What order do I send what? Read the documentation, right? Why can't the design be clear enough? I don't need to look at the documentation where the code itself is self-expressive. That becomes extremely important. Well, for example, order 3. What in the world is 3? I don't know. Document it. Large cup. Or what if I send the enum to it? It becomes self-documenting. Maybe it reduces errors too. That becomes a lot easier to work with. So in other words, we want to really reduce commenting and write more expressive code, and don't use comment to substitute for good code. Instead, express why and not what. That becomes extremely important. Avoid long methods and apply the SLAP principle, single level of abstraction principle. And what does this say? This basically says, if you write long methods, it becomes completely unmanageable. But how long is a long method really? Well, long methods have several problems. We can sit down and talk about all these problems, but how long is really long? It turns out it's not the length of the code, but it's the level of abstraction in the code. So when you look at the method, don't look at vertically how long it is, but look horizontally how wide it is. The more the indentation is, the worse the code is. It's even worse if people don't indent. That's a different story. But the point really is that you don't want multiple levels of indentation in the code. Well, the next thing I want to emphasize is give good names for variables. This is insane. When I watch programmers, I begin to cry when I see them give names for variables. It's absolutely random. Sometimes you look at the code, it's like the cat walked on the keyboard to select these variable names, right? Because there's no way to know what these things mean. So programmers, who are those? One who can name their children quite easily, but have a hard time naming their variables. My wife came to me and said, we're going to have our first son. What name do you want to give to our child? Here's the name. And she's like, wow, that's it. So quickly. You didn't even think for a minute. I said, sweetie, that's the name for our children. Now, if you will leave me alone, I got to figure out the variable name for my code, right? I mean, it's really hard for us to come up with variable names for code. Naming children is very easy. Naming pet is very easy. So we take a lot of difficulty in naming variables. Variable names represent abstraction. I came across this code for a client, and I asked them, do you mind if I take a photo of this? They said, okay, take a photo. What a big deal. Well, you may say, what's big deal about this, Venkat? You took a photo. Well, this is a product where the people who maintain this code are very advanced programmers, and the product is expensive. You have to pay a lot of license to get it. But what really excited me was not this code, but what I saw below this. It said, God help me, I have no idea what this means. And these are programmers leaving messages in the code because they couldn't maintain the code. So I have this feeling, you go on an expedition, you climb down this cave, and when you get to the bottom of the cave, on the wall, there's a message written called help. And then look down, there's bones in the bottom. That's how I feel about these programmers. These were their dying message, right? And they took the last breath and said, help me, I can't maintain this code anymore. That's how we feel about this a lot of times. Variable names represent abstraction. We have to be very careful about it. If you cannot name a variable or a function appropriately, it may be a sign that you have not actually understood the true purpose of this code. So a lot of times we have difficulty naming things because we haven't understood what these things actually mean. And until we do, it's really hard to give a good name for these variables. I want to emphasize about tactical code reviews. I cannot overemphasize this. Tactical code reviews are very helpful to remove a lot of problems from code. Peer reviews can catch up to 60% of defects in code. And keep in mind, when you are reviewing code, I'm not interested in bringing everybody into a room to do the reviews. That is not the purpose. When you bring everybody into a room to review the code, nobody likes it. We do tactical code reviews. So for example, first task I finish, I'm going to ask him to review the code. The second task I finish, I'm going to ask him to review the code. While he's reviewing my code, somebody else, maybe me, would be reviewing the code he wrote, and we keep rotating among the people to write the code. I'll be honest about it. You could ask me, hey, how is the code you write? I'll be very honest about it. I write terrible code. And you may look at this code and say, oh my gosh, you speak a lot, but how terrible your code is, Venkat. Well, that's how my code is when I write it. I'm not good at writing code, but I'm extremely good in finding fault with other people's code. So what I've realized over time is, rather than pretending I can write a really good code, I write crappy code, and I give it for a review, and then I review somebody else's code, and in the end, we both have better code. And that is the whole idea. We cannot write good code in one sitting, but we can get to better code by reviews. That's extremely important. But keep in mind, reviews are very sociological. So one recommendation is, I never tell people how their code sucks. You don't need to be doing that. What is important is you always tell them how they can improve the code. So always tell them what they should do rather than what they did bad, and that becomes a better way to really do code reviews and becomes very useful also. So facilitate these tactical code reviews. And the last recommendation I have is probably one I can emphasize is one thing I've changed myself. If you ask me, there's one thing I do differently in the past about 5 to 10 years than I did before. That is reducing state. I used to create bloated object-oriented code. Now my objects are a lot lightweight. They don't have as much state as they once used to. Reduce the state. Well, think more, type less, aim for minimalism, fewer states, less mutability, and just enough code for the known relevant parts of the problem. So we tend to write way too much code. How many times have you seen programmers sit down and start writing fields and getters and setters without really focusing on the real problem they should solve? I never want the state to be self-fulfilling. I want the state always to fall in place to serve the needs and the behavior of the object. So I bring in states much late now than I used to in the past. So messing with the state is the root of many problems, both in software and in politics. So getting a little philosophical, this is why countries fight with each other, because they mess with each other's state. This is really dark times, but that's what we see. When people mess with state, things don't go really well, as you all know. And of course, mutability needs company. It often hangs around with bugs. The more mutable a code is, the more bugs normally there are, and this is very striking when you see this. So we talked about 12 ways to reduce, improve the code and make it suck less. And these 12 ways can help us a great deal in generally writing better quality code. But I want to leave behind a few departing thoughts with you. You want to schedule time to lower technical debt, but also keep in mind to have time for slack time to improve and innovate. You want to maintain high cohesion and low coupling. You want to deliberately program with intention. You want to avoid primitive obsession. You want to prefer clear code rather than clever code. Apply the principle of writing to writing code. Well, focus on commenting why. Don't comment what the code is doing. Avoid long methods using single level of abstraction. Always create better names every single time. Avoid meaningless and single letter variables as much as you can. Do tactical code reviews, but also reduce state and reduce mutation in your code. But just to leave these thoughts, I'm going to say the very first step in becoming a better programmer is to let go of the conviction that we can do it once and get it right on the first write. It's never about writing code. It's always about rewriting code. And we are insane in our field where we think we can sit down and write the code in one sitting and walk away. It's important for us to remember that the real challenge and the real fun is in rewriting code, and we have to rewrite it several times for us to get better at writing the code. That becomes extremely important for what we do, and we have to work towards that. So if you're interested in downloading the example in the slides, you are most welcome to download it from there. I hope you found that useful. Thank you.